Number 1, it says triangle ABC is a right triangle with the right angle at ABC. So we start by drawing a right triangle. And to label it correctly, it says the right angle is at angle ABC. So that means that B is the vertex. That's where the right angle is. Find BC, so that's our X here, if AB is 9 and AC is 14. So here we have a right triangle with two sides looking for the third side. And we know that is Pythagorean theorem. So C squared equals A squared plus B squared. C squared is always our hypotenuse, our across from the right angle, so we call that 14 squared equals A squared, which I'm going to use X, plus B squared, which I'm going to use 9. 14 squared is 196, and that equals X squared plus 9 times 9, which is 81. I'm going to subtract 81 from both sides of my equation. 196 minus 81 is 115. So 115 is my X squared. And to find my X, I take the square root of both sides of my equation. So second X squared, 115. And that gives me 10.72, but we want to round to the nearest tenths. So X is approximately 10.7. Number 3, we're solving for X. Because these lines are parallel, that means that this angle is congruent to this angle, which is also going to mean that these two sides are congruent. So this is the same as X over here. So the right triangle we have has a side looking for the third side. So we're going to use Pythagorean theorem again. Pythagorean theorem says C squared equals A squared plus B squared. C is across from the right angle, the hypotenuse, 9.4 squared, equals A squared, I'm going to call X my A, plus B squared, which is 8, and I'm going to square it. 9.4 squared is 88.36. Remember, we don't round until the very end. We use 4 digits up until the very end. So 88.36 equals X squared plus 64. I'm going to subtract 64 from both sides of my equation. So I'm going to subtract 64 from 88.36. And that gives me 24.36. 24.36 equals X squared. So I find the square root of 24.36 in order to get X. So second square root, second answer. That'll take the square root of this answer, 24.36. So X is equal to, rounding to the nearest tenths place, 4.9. Okay, number 5. If the foot of a ladder is 15 feet from the base of a building, how high up the wall of a building does a 60-foot ladder reach? So the foot of a ladder is 15 feet from the base of the building. So here's my building. Here's the base of the building, and the foot of a ladder leaning up against the building would be here. So the ladder is 60 foot, and the foot of the ladder from the base of the building, foot of the ladder to base of the building is 15 feet. And we're looking for how high up the wall does the 60-foot ladder reach. So how far is this distance here? So once again, we have two sides looking for the third. We use Pythagorean theorem. C squared equals A squared plus B squared, where C is 60 and we square it because it's opposite the right angle, it has to be C, equals a squared, I'm going to call x my a, plus b squared, which I'm going to call 15. 60 squared should be 3600, which equals x squared plus 15 squared. 15 squared is 225. I'm going to subtract 225 from both sides of my equation. And I get 3375. I'm going to come down here. 3375 equals my x squared. And in order to find x, I want to take the square root of both sides of my equation. So the square root of 3375 is 58.09, which we want that to the nearest tenths. So x is 58 point, round this 0 up to a 1. Okay, number 7, we're going to find the value of the variables. So we are given one side and one angle, and we're looking for a third side. Using your graphic organizer, when you're looking for the third side, or second side, sorry, and you're given one side and an angle, if the angle is a 45-degree angle, you're using n square root of 2. So opposite the 45 is n, opposite this 45 is also n, and opposite this 90 is n square root of 2. So now everywhere we see, well, first we have to figure out if we have n, which we do. N is 9. They clearly tell us that n equals 9. So now everywhere we see an n, we're going to replace it with a 9. So my variables m is 9 and n is 9 square root of 2. N on this side is 9 square root of 2, not to be confused with the original n that we found. Number 9, we have one side and one angle, looking for the second side. And when one of the angles is 60 degrees, that means we're using special right triangles, 30, 60, 90. Opposite the 30 is t, opposite the 90 is 2t, and opposite the 60 is t square root of 3. So the side that has a number next to it is 8. So we want to solve for t. 8 equals t square root of 3. So we're going to divide both sides by the square root of 3 in order to get t. So t is equal to 8 over the square root of 3. Everywhere we see a t, we now replace it with 8 over the square root of 3. Here we replace it with 8 over the square root of 3, and then clean it up a little bit. 2 times 8 is 16, so this is 16 over the square root of 3. So y equals 8 over the square root of 3, and x equals 16 over the square root of 3. Okay, number 11, we have one side and one angle, looking for the triangle represented by the above drawing. What is the length of XC? So we're looking for a second side, and one of the angles is 45, so this is a special right, 45, 45, 90. So opposite the 45 is n, opposite the 45 is n, opposite the 90 is n square root of 2. Our next step is to identify the side that has a number next to it, which is 15. Since n is already solved for us, all we have to do now is erase and replace. So everywhere we see an n, we erase it and replace it with 15. So x, or side xz, which is what they asked for, is equal to 15 times the square root of 2.